Now we've talked about normal distributions. An important side point of normal distribution is a standardized normal distribution, and that's what we're going to talk about here. We've actually already been introduced a little bit to this. Do you remember back in lesson 7 when we talked about standard deviations? We introduced a concept called the z-score. Well, starting today, the z-score is going to be a critical part of everything we do for the rest of the semester. Okay? So here's how we introduced the z-score. We said we want to see how an individual data point fits in with the mean and the standard deviation of a particular data set. The z-score then indicates the number of standard deviations a data point is away from the mean. And here's the equation I showed you to calculate a z-score. Just simply take its value, subtract it from the mean, see how far away it is, and then divide it by standard deviations. Then it'll give you the number of standard deviations your point is from being away, how far it is away from the mean. This is our z-score. Now, we did this for only one data point in the past, but we could do it for all data points in a distribution. Okay, let's back up for a second. Let's do this. What is the z-score of the mean? These are just a couple of very simple calculations that I'm going to show you here. What would be the z-score of the mean? Why don't you guys take a pause? Go ahead and pause this video, use this equation here, and say x is going to be equal to my mean. What should the z-score be? Okay, so the z-score for the mean would be, you just put your mean in for x, so you end up having the mean minus the mean, which is 0. And this actually makes sense because remember the z-score is the distance that a point is away from the mean. So what is the z-score of the mean itself? It doesn't have any distance from the mean. It is on the mean. It is the mean. So its distance should be 0. The distance from itself is 0. Next question, what's the z-score of a value 1 standard deviation above the mean? Again, go back to this equation, see if you can figure that out, knowing that x is going to equal the mean x bar plus s. Okay, here's that calculation then. So if we take our value as the mean plus s, so there's the mean plus 1 standard deviation up, we subtract out the means cancel, they disappear, and we're left with s in the numerator. So s divided by s is 1. Okay, so 1 standard deviation above the mean gives you a z-score of 1. This makes sense. You're 1 standard deviation above the mean. The z-score tells you how far away you are from the mean. You're 1 standard deviation away from the mean, so the z-score should be 1. All right, if we were to convert all values to a z-score, so in the graph here on the left, you have a normal distribution with an average of 6 and a standard deviation of, looks like 1.7, maybe 2, somewhere around there. If we were to take every single point and apply it to a z-score, then that takes my distribution and it shifts it. Shifts it so that now the center of my graph is now on 0, and it changes the size, it changes the shape so that it has a standard deviation of 1. And that's what you're seeing now on the right side of your screen here. This is 30,000 standardized samples. And you can see, hope my picture isn't in the way, that all these values are now between -4 and 4. The center's at 0, and the spread gives me a standard deviation of about 1 in either direction. Okay, that is a standardized normal distribution where we take the mean and we shift it so that its center is now at 0, and the standard deviation, and we shape it so that its width is now 1. Okay, this is going to be very helpful for us because now we can go back and forth between our regular data and our standardized data. We use the standardized data to do all our calculations and then relate it back to our regular data so that we get some answers. All right, let's look at a few things that we can do with standardized normal distributions here on Desmos. So I have here a simple normal distribution, and I showed you in the last video that we can take the area of a left value, and that will give us the probability of having a value less than that number, right? But what's the probability greater than that number? Well, we can easily plug that into the calculator. Just simply shade the area to greater than and make that calculation. However, I hope that you have seen something very important here. Remember what I said about the total area underneath the whole curve. The whole curve has a total area of 1. So that means that these two areas are complements of each other. Remember what we meant by a complement? So I have the probability that x is less than -1 is 0.158655. If I take 1 minus that, I get 0.8413447. Hey, and that's the probability of being greater than -1. Okay, so if you want to find the probability left of, wrong one. If you want to find the probability left of a value, you could just use your calculators to get this area. Again, I haven't shown you how to do that quite yet. You see how to do it on Desmos, obviously. But I haven't shown you how to do it with a z-table or TI-84 yet. I will. But whatever your area is to the left, that's the probability of getting a value less than whatever this value here is, -1. But if you want instead the probability on the right, then we could take that probability on the left, take its complement, and that will equal the probability on the right. All right, that tells us if we have one value, what's the probability of having less than that? It also tells us the probability greater than that. Here's another interesting scenario that we're going to have to deal with. What's the probability of what is the probability of randomly choosing a number between two values? So in this case, I'm talking about what's the probability of having a value between -1 and +1.5. Well, a couple of different ways to do this. I like to think of it this way. Remember that the area of the total curve is 1. So what if I take that whole area and I subtract out this tail and this tail? So I take the two red curves, I find what their probabilities are together, and then I take the complement of that. So what are the two areas together? 0.15. Probability of a value less than -1 is 0.158655525. And the probability of a value greater than 1.5 is 0.066807201. So together, the probability of a value in either of these two tails, I don't care which, just one of them, is going to be 0.22546. That's given to us here. So what's the probability in the middle? It will be the complement of that. 0.77453759. And that would be this green shaded area in the middle. And there we have it. We've got the area in between 2 points. Now, we've seen this before. Think back about lesson 7, measures of spread. We talked about standard deviation. We talked about z-scores. And then one other topic I taught you there was called the empirical rule. And we said, what's the probability of having a value within one standard deviation of the mean? Do you remember what that was? 68%. You're welcome to go back to the lesson 7 videos and check that out. But the probability of being between plus or minus 1 within one standard deviation of the mean is 68%. Well, what if I take this and I shift it so that my green area is now between plus and minus 1? This is that scenario we talked about before. Now we can calculate this area under the curve, this green area, and it turns out to be 68%. There it is. When we talked about the empirical rule before, I said the probability of being within one standard deviation of the mean is 68%. And then I followed that by saying, I'll show you why later. Well, it's later. It is time. This is exactly how we get that. The area within one standard deviation of the mean is 68%, specifically 68.3%. What about 2 standard deviations of the mean? So within 2 standard deviations of the mean, we're going to spread it out a little bit. But remember what that probability was? It was 95%. So if I shift this to -2 and this to +2, what's that area coming out to be? 95.4%. 68% chance of being within 1 standard deviation of the mean, 95% chance of being within 2 standard deviations of the mean. Do you remember what it was for 3 standard deviations? I hope you remember. If not, it is 99.7. 68% within 1 standard deviation of the mean, 95% within 2 standard deviations, 99.7% within 3 standard deviations. All right. So, summary. What's the area underneath the curve? The total area is 1, meaning that represents the entire data set as 100% of the data. We can easily use our calculators to find the probability to the left of a value. How do we find the probability to the right of a value? Take the complement. And then how do you find the probability of being between A and B? It's just the area under the curve between A and B. But we take the total area of 1 and subtract off the left tail, subtract off the right tail. All we're left with is the area between A and B. Okay. This last point I have on this slide talks about percentiles. Remember, we talked a bit about percentiles back in lesson 6, very briefly. I'm actually going to hold off till another video to talk more about that, but we can even use normal distributions to find percentiles. Okay, now in the next videos, I'm going to show you how do we actually calculate these probabilities and how do we find the z-scores with those probabilities.